Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0616 indicates a low voltage condition in the starter cut relay diagnosis circuit for the Honda Pilot models from 2016 to 2022. This issue typically affects the starter cut relay, which plays a pivotal role in controlling the starter motor's engagement. The relay is located within the auxiliary underhood fuse/relay box, an essential component that protects and supplies power to various electrical systems within the vehicle. If this relay fails, or if there is insufficient voltage, the engine may fail to start, indicating a serious issue. Understanding this error and the components involved aids in effective troubleshooting, ensuring a quick return to reliable vehicle performance. The starter cut relay is a fundamental component in the Honda Pilot, tasked with managing the starting system by allowing electrical current to flow from the battery to the starter motor. Located in the auxiliary underhood fuse relay box, this relay ensures that power is delivered only when appropriate conditions are met, safeguarding against potential overloads or electrical faults. A low voltage condition, such as that indicated by Diagnostic Trouble Code P0616, can lead to insufficient power reaching the starter motor, preventing it from engaging. In practical terms, this could mean the engine won't crank or start. Addressing this DTC typically involves a thorough examination of both the relay and related wiring to identify the root cause of the low voltage condition. There are several possible causes for the DTC P0616 in the Honda Pilot. One primary factor could be poor connections, which can arise from corrosion or wear over time, causing intermittent contact. Loose terminals are another common concern in electrical systems. If terminals at the starter cut relay or powertrain control module (PCM) are not secure, they can disrupt voltage signals. Additionally, the starter cut relay itself might be faulty, resulting in an inability to control the power supply effectively. Each of these issues could lead to the low voltage detected in the circuit and must be thoroughly investigated during the troubleshooting process to ensure the system's integrity. The symptoms associated with DTC P0616 can significantly impact the vehicle's functionality. The most apparent symptom is that the engine may fail to start altogether, leaving the driver stranded. Additionally, drivers may experience intermittent starting issues. At times, the engine may crank normally, while other times it will not respond. Furthermore, you may notice dashboard warning lights activating unexpectedly, indicating potential electrical issues. These symptoms are critical indicators that should prompt immediate diagnostic testing, as they could potentially point to more extensive failures within the vehicle's electrical system. The first troubleshooting step involves verifying the problem by turning the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Following this, you will clear the DTC using the Honda Diagnostic System, HDS, which resets the vehicle's error codes and allows you to check for any new occurrences of the problem. It's important to check the starter cut relay parameter values via the HDS. Specifically, you are looking for voltage readings below the specified threshold of 1.02 volts. If the conditions match this threshold, the next step can be initiated, confirming that a failure has occurred. If not, it may suggest an intermittent issue or that system is operating normally at that time. In the second step, you begin by switching the vehicle off and ensuring all systems are in a safe state. Next, you will check fuse number B17, a 7.5 amp fuse found in the auxiliary underhood fuse relay box. This fuse is crucial as it protects the starter cut relay circuit. Inspecting the fuse for damage or blown conditions is vital. If the fuse is intact, you will proceed to the next step. If the fuse is blown, it indicates a probable short circuit, necessitating further investigation and replacement before testing the system further. After confirming that the fuse B17 is intact, you proceed by removing it from the auxiliary underhood fuse relay box. With the fuse removed, turn the vehicle to the on mode again to conduct voltage testing. It's imperative to monitor the starter cut relay's voltage through the HDS, aiming for a reading above the threshold of 1.02 volts. If the voltage meets this threshold, it indicates that the wiring and connections leading to the starter cut relay are likely functioning correctly, and you can move on to the next troubleshooting step. If not, it suggests a potential wiring issue or further problems with the circuit, necessitating immediate attention. In step 4, turn off the vehicle once again to safely access the components. The next step is to remove starter cut relay 2, located within the auxiliary relay box. Once removed, conducting a test on this relay is crucial to ascertain its operational status. If the relay tests as functional, it indicates that there might be a short circuit in the wiring, STRLD, leading between the B17 fuse and the relays. In this scenario, repairing any identified short within this wiring circuit is essential, and if necessary, you may need to replace components within the auxiliary underhood fuse relay box. However, if the relay is found to be faulty, simply replacing it with a new relay is the rapid solution to the problem. The final troubleshooting step involves a more detailed investigation into the wiring components. Begin by removing starter relay 2 from the vehicle. Then, use the Honda Diagnostic System, HDS, to jump the SCS line, allowing you to test the system under load conditions. It's important to wait over 1 minute after performing the jump, giving the system adequate time to stabilize. After this period, disconnect the PCM, Powertrain Control Module, Connector A, and measure the resistance between the designated test points. You're specifically looking for a resistance reading of 1.0 m-ohms or higher. If the reading meets or exceeds this value, you should consult any authorized service information or consider substituting with a known good PCM for verification. If it falls short, repair a potential short in the wiring between the PCM and fuse while ensuring the B17 fuse is in place once again. Final repair verification is an essential step to ensure that all repairs and replacements have effectively resolved the issue regarding DTC P0616. Begin by confirming that all wiring connections, terminals, and components are properly secured and that there are no residual faults or concerns remaining unaddressed. Retest the system using the HDS to clear any previous error codes and observe whether the starter cut relay circuit operates within its specified parameters. Finally, verify that the vehicle starts without any issues, confirming that the repair efforts have restored functionality. It's critical to review the test data to ensure that no present error codes remain, reaffirming a successful repair. To prevent issues related to DTC P0616 in the future, incorporate regular maintenance of the electrical system into your vehicle care routine. This should include periodic checks on the electrical system components, such as the starter cut relay, wiring harnesses, and related terminal connections, ensuring they are free of corrosion and damage. Frequent inspections can help identify any wear or degradation before they lead to significant electrical failures. Additionally, ensuring that all connections are clean will minimize the risk of resistance buildup, a common cause of low voltage issues. Regular visits to a certified mechanic can assist in maintaining the integrity and reliability of the vehicle's starting system. In conclusion, the Diagnostic Trouble Code P0616 is a critical indicator of issues within the starter cut relay system of the Honda Pilot from model years 2016 to 2022. Understanding the role of the starter cut relay in regulating voltage to the starter motor highlights its importance in the vehicle's overall functionality. A thorough troubleshooting process, from problem verification to final repairs, ensures that root causes are identified and addressed effectively. Maintaining the electrical system through regular checks and preventative measures can help cultivate long-term reliability and performance in these vehicles. As with any vehicle diagnostic, attention to detail and proper methodology will yield the best results in restoring functionality and safety. Please like and subscribe to the channel. See you next time.